Okay, the gradient vector, here it is. You know, the gradient vector is actually, there's nothing really to finding the gradient vector. Okay, it's a vector. It's good to know that it is a vector. I guess, you know, it'd be good to write the things on there. And its components are just partial derivatives. So if you have a function of x and y, you're just going to take the partial derivatives, okay, and then you're going to, you know, just make a vector out of them, okay. And then if you're given a point, okay, then you can go ahead and evaluate it. Okay, so let's just do one example, and I'm not going to spend too much time on the actual partial derivatives because we know how to do it. So let's say f of x is equal to, I don't know, x squared plus 2y to the third plus 4z squared. There's our function of x, y, and z. So I need partial of x. What's that going to be? That's just going to be 2x. Partial of y, that's just going to be 6y squared. And partial of z. And that's just going to be equal to 8z. Okay, and I want to find that at the point 1, 1, 1. Well, del f is, you know, is what we call it, at 1, 1, 1 is equal to, well, it's equal to 2, 6, 8. Okay, really pretty easy to figure out. The important thing about a gradient vector is, I mean, it's actually so easy to figure out that I think people kind of just forget what it is. Okay, so here I got some data here from the National Weather Service, and this is seawater temperature. Okay, surface temperatures of the seawater. Okay, and meteorologists use the gradients all the time. They're called temperature gradients. Okay, and I don't know if you can read it, but basically, you know, the red water obviously is the hot water, the blue and maybe purple stuff's even cooler. So notice, like, from, I don't know, say we're in like I don't know, we're in like Eureka, California. Okay, we're up there. So we're up there in Eureka, California, and you know, if I projected all this onto a coordinate plane, and I took the gradient, we'll call it del E. Okay, let's just look at the temperature difference. You know, it would probably point somewhere like this. Okay, because look this way. It takes a long time I mean, as we're going, you know, in this direction, it looks like the water temperature changes pretty slowly, but over here it changes pretty quick. And likewise, down here in South America, you know, just right off the coast of Ecuador, like say I went to like the Galapagos Islands. So I'm at the Galapagos Islands, and if I took the gradient there, it would probably point in this direction. Okay, so I'd get the strongest increase in temperature right there, and that's basically the idea around it. Okay, now granted, this function right here would be extremely complicated. I mean, there's no way you could do it by hand. I mean, this is a computer-generated model, but computers actually use this formula right here to figure out what the gradient vector is. Okay, so you know, it's all programmed into the computer. The computer just calculates it, because it would seriously, I mean, it would take you forever to actually work with that. So it'd be real complicated. But that's basically what the gradient vector is in a nutshell. So, you know, and if you're in the mountains and you want to walk up the steepest section of the mountain, you would want to take the gradient of your current position point, and that gradient would point in the direction that you should go if you want to get like a really good workout. Okay, so there is my video on the gradient vector, and I mean, there's not much to it. Not much to it. Easy. Yeah. So